In this section, we're going to talk about real number operations. Now, basic operations are the ones that you're very accustomed to. Addition, and you may not know the specific terms here, but you have an add-in, and we should know that that equals a sum. For subtraction, you have a minuend minus a subtrahend, and we should all know that that is difference. For multiplication, you have a factor multiplied by a factor, and that will always give you a product. For division, we have a dividend divided by a divisor, which gives us the quotient. And then for exponentiation, we have a base and an exponent. So we have a number taken to a specific exponent here. The absolute value of a number, which is represented by these two lines on either side of the number, is the number of units or the distance between 0 and the number's graph on a number line. This will always be positive or 0. So for example here, the absolute value of 5, well, that is going to be how far away the number 5 is from 0. And because we're talking about distance, that is going to be 5. So if we were to take the absolute value then of negative 5, even though it's in a different direction, is the same distance away from 0, which is 5. Order of operations, often referred to as PEMDAS, is how we should simplify our numbers when we have different operations. So PEMDAS, often we have parentheses here, but really that is all grouping symbols. Those are the things that we want to do first. Then we're going to move to our exponents. Now, multiplication and division is together, and so we're going to do all multiplication and division together from left to right, whichever comes first, whether it's multiplication or division. And the same is true for addition and subtraction. We're not going to do all the addition, then the subtraction. We're going to do addition and subtraction together from left to right, whichever comes first. And so let's do a few of these examples. When we have multiple grouping sets like we do on this first one, we're going to work on the inside out. So we're going to take this first set and we're going to go left to right. 4 minus 5 is -1, and -1 plus 4 is 3. So that takes care of our first grouping. And then we're going to do our next set of grouping. 5 minus 3 is 2. We'll multiply that by 2, and our answer here will be 4. Let's look at number 3. For number 3, we actually have an exponent within our grouping. So we're going to do that exponent first, and then we have -2, and that is a multiplication, times -2 times a -2 on the outside. And I just put parentheses here to indicate that negative, but we are going to multiply this 2 and -2 here. And so we have 16 minus a -4. And don't forget we are multiplying by that -2. In here we have plus a positive, so we end up with 20 times that -2, which gives us a -40. So go ahead and take a few minutes to work on number 2 and number 4, and then you can check your answer. An algebraic expression is a constant, a variable, or a combination of these symbols and operations signs that is used to represent a number. So for example, you could have an x, you could have a 3x, you can have addition and subtraction between those. But these are algebraic expressions. You have some specific types of expression, and so you can simplify them when you use the substitution property. The substitution property says that if two things equal, for example, A equals B, then A can replace B in any expression to produce an equivalent expression. We use the substitution property to help us evaluate algebraic expressions. Evaluate is when you have an algebraic expression that contains variables and you substitute the value for each variable into the equation so that you can simplify it. For these examples, you've been given an algebraic expression, y times z plus y divided by 4, and then they've told you what the variables represent. So you're simply going to take the variables and plug them in. Instead of y, we're going to write 2 times z, which was 1, plus y, which was 2, then divided by 4. And then we're simply going to use our order of operations here. We'll do our parentheses first, then we'll do our multiplication division from left to right. So 2 times 3 is 6. 6 divided by 4, that does not go in evenly, so we're going to leave it as a fraction. And then we're going to reduce it. Remember, just divide it by the common factor here, which is 2. So you should have it with 3 halves for that one. The same is true even when you have fractions. So in this case, we have 4 minus z over x plus z. Z is 1. So we're going to rewrite this using those variables. 4 minus 1 over 3 fourths plus 1. Remember, this is just keep, change, flip when we have this division here. Keep the 1, change it to multiplication, flip it. So 1 over any fraction is just the reciprocal. Remember, though, that in order to add and subtract fractions, we have to have a common denominator. And so the common denominator here is going to be that 3. Remember, this is the 4 over 1, so we multiply top and bottom by 3. 4 is the same thing as 12 thirds. We are subtracting 4 thirds plus a 1 to get a common denominator is going to be 3 thirds. Remember, once you have your common denominator, to add those fractions or subtract, you just do your numerators. So we have 12 minus 4 is 8, plus 3 is 11, and we keep our denominator the same. So a real life scenario is when we take something like we have the formula here for converting from Celsius to Fahrenheit, we evaluate it by plugging in what we know, and then we solve. And so in this case, to convert from Celsius to Fahrenheit, the equation is 9/5 times the Celsius plus 32. And so we simply plug in that. So we're going to say 9/5 times 15, and I'm going to write that 15 over 1 plus 32. When we're multiplying fractions like we're doing here, we can cross cancel that. The 5 and the 15 cancel to 1 and 3. So we have 9 times 3, which gives us 27, plus that 32. And we will get that 15 degrees Celsius is 59 degrees Fahrenheit.